Okay, we're going to work out the relative atomic mass in this video. Just let's get one thing straight before we start. A very common mistake is to think this is the relative atomic mass up here, or that there. It's not. That is the mass number. The mass number is just simply the number of protons plus the number of neutrons, whereas the relative atomic mass, this is the mass of an, if you like, it's the mass of an average atom. Okay, so that's taking into account the numbers of each isotope. You've got two isotopes of chlorine there, and if you're wondering what this relative bit means here, that's a technical term, relative. Well, it's relative to to the mass of carbon-12. So the carbon-12 isotope, and that's defined as having a mass of exactly 12. And I always used to think, when I was at school, I always used to think, why do they do that? Why don't they just say, use one hydrogen, say relative to the mass of one hydrogen, and make, compare everything to that? Well, there's a reason for that. It's because hydrogen is a bit of a weird atom, and it's the proton in hydrogen is slightly heavier than any other proton, really. So it wouldn't really be that good a comparison. Anyway, don't worry about that. But if they do occasionally ask what's it relative to, and it's relative to the mass of carbon-12, that's 12 mass units. So don't confuse it with the mass number, which is different for each isotope. Right, so let's see how to work it out. Right, so here we've got the percentage data. You've got 37 chlorine, 25%, and 35 chlorine is 75%. So the best approach here is say, right, in 100 atoms, you're going to have 25 of the 37 chlorine, and the total mass of that is going to be 25 times 37, which is equal to 925. And also in 100 atoms, we are going to have 75 of the 35 chlorine, and the mass of that is going to be 75 times 35, and that is equal to 2,625. So then we're going to say, right, what is the mass of 100 atoms altogether then? We are going to have to add that number and that number together, and that gives us 3,550. So we know 100 atoms weighs that much. So we're going to say, therefore, the average mass of one atom, that's for 100, is going to be 3,550 over 100, and that's going to be equal to 35.5. That's how we work out the relative atomic mass of chlorine, sometimes given that symbol AR. I just do a slightly more complicated example. So this is an atom, this is strontium, which is made of 3 different isotopes. Okay, so here's strontium. There's 86, 87, and 88. So obviously they've all got the same number of protons because they're isotopes. So let's work out, let's say again in 100 atoms, how many 86s we have. Now, this is a bit weird because we're going to have a fraction, a decimal, so we're going to have 9.9 atoms of 86. Strontium, what's the mass of that going to be? It's going to be 9.9 multiplied by 86, which is equal to 851.4. Do the same for this one. So we're going to have 7 atoms there. Don't have to worry about a decimal with that one, of the 87. So that is going to be 7 times 87, which is equal to 609.0. And finally, for this one that's of 88, we're going to have 83.1 of those atoms. So that's going to be 83.1 multiplied by 88, which is equal to 8,773.2. So what's the mass of 100 atoms? The total mass of 100 atoms is going to be that, which is equal to 8,000. Sorry, that's a mistake there. That should be 7,312.8, and so it's going to be that, which is equal to 8,773.2. Right, so if 100 atoms weigh that much, what's the mass of one atom? Average mass of one atom is going to be 1/100th of that. So 8,773.2 over 100. And I just give it to one decimal place. Usually in the question, it will ask you to give the number of decimal places to give it to. So I'll give that to 87.7. That is the answer. The relative atomic mass of strontium. You may not be that happy about, you can't have 0.9 of an atom. Well, if you didn't want that, you could just say in 1,000 atoms, and then you'd end up with all, you'd have 99 of those atoms. And then at this last step, instead of dividing by 100, you divide by 1,000 and you get exactly the same answer. Okay, so that always used to be an A-level kind of skill, and they've moved it down to GCSE in the last few years. So it was quite a straightforward thing to do when you know how to.